Welcome to Interview Analytics. We are bringing a new series dedicated to data engineering interviews. The current hiring trend clearly shows that the data engineering roles continue to grow. Organizations are investing heavily in data analytics and AI driven pipelines. Whether it is a startup or big tech, the demand for scalable data pipelines and analytics team is rapidly increasing. So in today's video, we will be focusing on data engineering interview question and their answers for 2026. These questions are taken from the recent interviews at companies like Amazon, Google, and Meta. So if you are preparing for 2026 data engineering interviews, this video can serve as a strong roadmap for you. So let's start this. So our first question is from the topic data modeling, that is star versus snowflake schema. So what is the difference between a star schema and a snowflake schema? So in a star schema, we have a central fact table connected directly to simple and wide dimension table. It is easy to understand and works best for analyst and BI team. Because the number of joins is low, queries run faster. This is why star schema is common used for dashboards and reporting workloads. Meanwhile, in a snowflake schema, dimension tables are further normalized into smaller subtables. This reduces data duplication and saves storage, but it increases the number of joins and the queries may run slower. Snowflake schema is used when you need strict normalization. One real life example of this can be in a sales analytics project. The team shifted from a snowflake model to a star model just because the dashboard queries were getting slow. After flattening of the key attributes, performance improved significantly. This clearly shows that the star schema is usually more efficient for analytics workload. One of the follow-up questions for the first one can be when to use what. So we can use a star schema when dashboard report performance matters. Analysts need simpler tests. Low latency queries are the priority. And we can use a snowflake schema when the dimensions have multiple hierarchies. There are multi-level information stored in it. And the storage efficiency is important. And we need to follow strict data modeling rules. One of the practical takeaways can be for most analytics team, a star schema provides a better experience unless there is a strong requirement for normalization. Moving to the next question, how to design a reliable and scalable fact table. So first step could be define the grain clearly. A single row should represent exactly one transaction, one event, or one item. Second step could be keep the fact tables lean. Store only numerical measures, and foreign key can be used to move the descriptive informations like name, label, address, text to dimension tables. Using of partitioning keys. Partition by date, event time, or any frequently filtered column can be used. If the data comes via streaming service and the data is very bulky, we can even partition it using hours. This helps reduce data scanning and lowers query cost. Using a columnar storage format. Formats like CSV is good for a small number of data when the number of rows is usually less than a million. When the big data is involved, formats like Parquet reduce cost and speed up queries significantly. Real life example can be high volume systems generate billions of records monthly. Using event date partitions and Parquet format reduces compute cost drastically. Teams often maintain daily or weekly summary tables so that the dashboards don't need to scan raw level data. Another question can be from SQL or database subcategory. How to optimize a slow running SQL query? Few of the checks could be, is there a full table scan? Are the joins inefficient? Is there sorting or disk spilling involved? Are the input output operations too high? And the solution for these could be like align the filters with partitions. Select only the required columns. Rewrite joins to avoid row explosion. Using of sort keys or clustering keys. And creation of summary tables for repeated workloads. An example of this could be a revenue dashboard while scanning 2 years of raw data. After adding daily aggregates, both performance and cost improved significantly. So our next question is from the topic AWS or Cloud Data Engineering. What does Athena do? Athena is a serverless SQL engine that lets you query data stored in S3. This data can be in any format like JSON, CSV, Parquet. There is no infra management involved in this, and we only pay for the amount of data scanned. Athena is especially useful for validating new data, sampling raw files before ETL, and debugging of pipeline outputs. One of the following questions of this could be like, how can we optimize the Athena performance, and what is the difference between Athena versus Redshift? To optimize Athena performance, we can use partition. We can use it by date, by hour, by months, depends on the frequency of data incoming. We can store in data compression formats like Parquet or ORC. Use of selective queries to reduce the scanned data. For the comparison regarding Athena versus Redshift, these two tools are built for two different operations. Athena is better for ad hoc queries, raw data exploration, and occasional workload. Meanwhile, Redshift is better for dashboards, heavy joining, and high concurrency workloads. The next question could be serverless versus server-based data processing. Serverless data processing includes AWS Glue, AWS Lambda, Amazon Athena. No servers are there to manage or provision. The scaling is automated and it is best for scheduled ETL jobs. The operational overhead cost is lower and we only pay for the usage or data scanned. And the most important part, the setup is faster. We don't need to provision each or everything. We just need to turn on the service and it will work. And after the job is done, it will downscale itself. Meanwhile, in a server-based system, a few examples can be like Amazon EMR service or EC2 service. We have a better control on the cluster size, the configuration, and the tuning of that. It is suitable for very heavy workload, long-running jobs, and large-scale distributed compute. It supports custom library, advanced Spark tuning, and specialized frameworks. But there is more operational responsibility. For example, maintaining the cluster health, scaling, cost control, these need to be done manually. Often most more cost effective for continuous or high volume processing. Our next question is from Big Data. Data lake versus data warehouse. As the name suggests, in a warehouse, everything is stored in an organized manner in shelves. Meanwhile, in a lake, we can store unorganized information also. So, a data lake stores raw, semi structured data. Schema is applied at the read time and it is flexible for machine learning and exploration. Meanwhile, in a data warehouse, it stores clean and structured data. Schema is applied at the right time and it is preferred for reporting and dashboards. Common setups can be S3 as a data lake and Redshift as a data warehouse. One of the follow-up questions from this could be storage formats. Whenever there is big data involved, we opt out from CSV or XLSX format and we prefer these columnar formats like Parquet, ORC. So why these formats are being used? There is high compression in this. Both formats compress data efficiently, which reduces storage and improves read performance. The columnar layout enables data storage to be a column by column instead of a row by row system, allowing engines to read only the columns required for a query. So for example, if we are only fetching one column, it does not read the other columns of that data. Optimized for data distributed processing. So these formats integrate well with big data systems like Spark, Hive, delivering a consistent performance across the large clusters. The practical takeaway from this could be like using a Parquet or ORC can cut processing time by more than half to formats like JSON or CSV. One of the practical examples that I have encountered is a single process that takes around couple of hours to process data in CSV gets completed in just a couple of minutes when we are using Parquet format. So the next question is from data streaming platforms. So what is streaming versus batch processing? So batch processing is where we have to analyze the data that is currently existing in our system. So it is suitable when we have the time where the results can wait. For example, there is daily reports or weekly aggregation reports. Meanwhile, where there is a flow of data coming in our system, we use streaming services. So it is needed where near real time data is required. Examples can be financial summaries can run in a batch, but fraud alerts rely on streaming systems like Kinesis. One of the follow-up questions can be Kafka versus Kinesis when we are talking about the data streaming platforms. Kafka is currently one of the most popular data streaming platforms. Kafka gives us more control, there is replay capability, the configuration retention is there, and it needs more operational work. Meanwhile, Kinesis is fully managed by the AWS. It is easier to maintain, but it is less flexible than Kafka. This covers the major areas like SQL, AWS data modeling, big data concepts, and streaming. Comment below if you want more mock interviews, system design walkthrough, or resume reviews. If you found this sessions useful, do subscribe to support the future content and keep learning and improving. See you in the next one.